So for this question, hold on. Yep, okay. So for this question, it wants the common ratio and it wants the sum of the first six terms. Now to get the common ratio is really easy. You get the second term, sorry, this is the second term, -9, and you put it over the first term, which is 3. So -9 over 3, and that gets you -9 over 3. That's -3. That's your answer right there. Easy. And then they want the sum of the first six terms of this progression. Now, to get the sum, there's a formula for it. It's G1 times 1 minus R, and R is to the power of n. It's just R, and R would be here, this number right here. It wants here the first six terms, so in this case it'd be 6, but it differs every time. And then over 1 minus R. So that should be our formula. So here we know that G1 is 3. So we're at 3 times. Now be careful to write this in bracket. We know that our R is R, for us R is the ratio, and we know that it's -3. So we do 1 minus, right in brackets, -3, the power of 6. Now you need to write this in brackets or else it won't work most of the time. And close brackets over 1 minus 3. Now write that in the calculator. You get here 3 times 1 minus 3, power of 6 over 1 minus 3. You get -546, and that's your answer. Let's say it wanted the first 8 terms, you just put 8 instead of 6, and that's your answer. But in this case it wants 6, obviously, so we're not going to overcomplicate it. And yeah, that's okay. So here's question 2. They want the sum, and there's two possibilities for the sum. But before I start, I'd just like to say that in the geometric expression, in the question itself, it just keeps going on and on and on. Here I just stopped at -80/3 because I can't write anything as a fraction, but we only need two terms, so that's a good thing. So since it doesn't say the amount of terms we need, like the sum of an amount of terms, that means it's a sum to infinity. And for sum to infinity, the formula is G1 over 1 minus R. It's as simple as that. So in this case, let's find the unknowns first. So G1, it's easy. It's first term geometric in the geometric expression, that's 90. Or let's just find R real quick. R is really easy to find. It's just the second term over the first term. So in this case, that would be -60 over 90. And you write that in the calculator, -60 over 90, and you get -2 over 3. So now we know that -2 over 3 is our R. -2 over 3 equal R. So I'm just gonna keep that over here. G1, you know G1 is the first term geometric expression, which is 90 over here. So we just do 90 over, right in brackets as always, just in case, 1 minus -2 over 3, and that should get you your answer. So let me just double check as usual. -2 over 3, and your answer would be 54, and that's the correct answer. That's it. So here it tells you in the given that the geometric progression 6 radical 3 x and then 72 radical 3 are the sequence itself, and they want us to find x. They give us the first term, they give us the third term, and we're trying to find x. Now, how can you possibly find x in this situation? We can do third term over the second term is equal to second term over the first term. So it's always 3, 2, 2, 1. And if that makes sense, like I'll just write it here. G3 over G2 equal to G2 over G1. Simple as that. I'm gonna have to erase that because that's pretty hard. Okay, I'll just whatever. So we do 72 radical 3 over x is equal to is equal to x over, let me just erase that, equal to x over 6 radical 3. Now you add that in the calculator. Let me just type it real quick. Equal to, ouch, yep, it is equal to 36. You do shift calc, and you get 36, and that's your answer. Yeah, that's it. And just to double check, if you want, you can do 36 which is your x over the first term, because second term over first term, 6 radical 3, so 36, whatever, I'm gonna fucking kill myself. Okay, so here it says an amount of $550 is invested at a bank that pays an interest rate of 7%. What's the amount of money accumulated after 4 years, right? They told us X dollars and 94 cents, so we ignored the 94 cents. So there's a formula for this. It's the amount of dollars invested, which we write as P1. It's times 1 plus whatever the percentage is. It's written as R, so 1 plus R percent, the power of n. Now n is the number of years. That's for compounded. That's when it's compounded annually, and you can see here it says it's compounded annually. So that's how you know, that's the formula for it. So $550, which is P1, that's the initial investment, times 1 plus 7%. Make sure to add the percent. The power of 4. Let's just write that on the calculator. 550 times 1 plus 7%, power of 4. You get 720.94. You ignore the 94 cents because here it said 94 cents, they only want x. So that's your answer right there, 720. Wow. So in this question, give us the function of y equal 1.5 power of x. So let's just see what you get. 1.5, the power of, let's say we want to put 1, right? 1 here, because that's probably the easiest thing to begin with. So when you put 1, you get y is equal to 1.5. So you write in the calculator, you just write like 1.5, the power of 1, like that, and your answer is 1.5. So when x is 1 over here, this should be 1.5, and you can see that's correct over here. I can double check that, and I'll do that in a second. But here, for example, it's around the 0.8 mark, so that doesn't work, and so on and so forth, every other question. Now some might hit, in this case none, others hit 1.5, but let's say there's two options that hit 1.5 where you just want to double check if it's correct. You put 1.5 to the power of 2 and you get 2.25. So here it's supposed to end at 2.25. Yep, so that's 1, that's 2, 2.25 is right here, and that's your answer. This question they gave us y equals 0.6 power of x is the dotted line and y equals 0.6 power of x plus 2 is the normal line. So just looking at the graph, the dotted line is like similar in every single graph, so let's just go with the normal line, which is the power of x plus 2. So here let's go 0.6 power of let's say we want 1 plus 2, right? We would get 0.21622 basically. So let's look at our options here. So x equal to 1, we need to get 0.216. Does that look like 0.216? Yeah, it does. So we'll just keep that as one of our options. Here, 1 again, x equal to 1. Does that look like 0.216? Not at all, so we just cross this out. And then here, also not at all, so you know, if you're wondering what I'm doing, you just go straight up till you find the normal line, and then you just go to the y-axis, see how far that is, and it does not look like 0.22 at all, so you cross that out as well. And the only option you have left is this one. That's it. And yeah, here in part B they told us y equals 0.6 power of x plus 2. So okay, I'm just gonna write it here. That's the eraser. 0.6 power of x plus 2. Alright, now so you can basically just write as 0.6 power of x plus 2 plus 0, because there's usually what's it called, a constant over here, and that constant right now is 0. So y is just this constant over here. Now since it's 0, you don't need to write it, but it's still there. Now let's say it was 0.6 power of x plus 2 plus 1. Now y would be 1. If it was 2, y would be 2. That's it. But as of right now, it is 0, so it would just be equal to y equal to 0. That's it.